Combinations and factorial notation. Factorial notation. I'll explain what factorial notation is by giving you an example. Suppose that 4 people, A, B, C and D, are running a race. There are 24 different finishing positions, and these are shown in this diagram here. So A could finish first and B second, C third and D fourth. However, A could finish first, B could finish second, D could finish third and C could finish last. And if you write out all the different combinations in the order in which they could finish, you end up with 24 different finishing positions. Now, the number of possible outcomes can be calculated by multiplying 4 by 3 by 2 by 1, which equals 24. And the reason we picked 4 is because we had 4 people to start with. And this 4 times 3 times 2 times 1 can be represented as shown by 4 factorial. And this notation 4 factorial means 4 times 3 times 2 times 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. Well, n factorial, so any number is n, then multiplied by n minus 1, then multiplied by n minus 2, then multiplied by ... until you get towards the end when you're going to have times 3 times 2 times 1. One key bit of information to remember, which could be useful in certain questions, is that 0 factorial is always equal to 1. So 0 factorial is always equal to 1. So if we want to find out the number of possible outcomes, we do factorial. But suppose we wanted to choose 3 letters from A, B, C or D. So we just wanted to choose 3 of them. So we could have picked A, B, C. We could pick B, C, D. Where the order does not matter, so it doesn't matter in which order. So we could pick C, B, D, but that's the same as saying B, C, D. There are only 4 different ways of this happening, only 4 different outcomes. And we can represent this by this symbol here, 4C3, where the C refers to combinations. So 4 letters, but we want to pick 3 of them, or 4 over 3. And this is a useful notation when we come and look at binomial expansion on the next video. And these combinations can be calculated by doing 4 factorial divided by 1 factorial times by 3 factorial. And if we check out that this is actually 4, well, we know that 4 factorial is 24 from above, and 1 factorial is just 1 times by 3 factorial, which is 3 times 2 times 1, which is 6, and that is 24 over 6, which is indeed equal to 4. So what is a general rule for calculating the number of combinations is shown here. So R items from a group of n items. So in the one we've just looked at, we wanted 3 items from a group of a possible 4 items. Well, this is the rule for it. So the n is the total number of items that we have available, and the r is the number of items we're looking to pick out. And the general rule is n factorial divided by n minus r factorial times r factorial. So in our workings above, from this equation up here, the reason that we got the 1 was because we did 4 minus the 3, which gave us the 1, and the r, which was how many, we only wanted to pick 3 of the 4 possible letters, so we picked 3 factorial there. Now, this rule is given to you in your formula book, However, you can also do this on your calculator. If you've got a Casio calculator, above your divide sign, you should notice you have an NCR button. And if you use that button, you can quickly find out the number of possible outcomes in an exam. However, you can also use the equation shown here. Now, this equation is going to become very useful in a minute when we look at the next video on binomial expansion.